Good evening, everyone. And I'd like to thank you for coming. I'd like to welcome Facit Homes. And so tonight we have three of the team. We have the founder, Bruce. We have Pedro, one of their longest-serving employee and technical wizard. And we have Jan, who some of you may know from her talks here about bamboo and building with bamboo and some of the workshops she's done. So have a good evening all. That's very good, thank you. And so it's very nice that all of the team are here to talk about this system, and I was looking at our kind of records, and Bruce first came and talked about Facit, or the system, which he'll explain in a minute, in 2008, and when it was relatively new, and as he's explaining, it's getting better and better. It's a really elegant kind of system that seems very simple. I mean, it isn't very simple, clearly, but it's very simply put together and very beautifully put together. So anyway, really nice to have the team here all to talk about it. So over to you. Thank you.
Hello. Can you hear me? That's all right. So, hi, I'm Bruce. I'm the founder of Facit Homes. I'm going to talk to you a little bit about some of the ideas behind Facit Homes and how we got there. And then Pedro's going to talk a bit more in detail about the actual system, and Jan's going to talk more about how we build. So, there we go. So, Facit Homes, we are a home manufacturer. We do everything from concept design, planning, detailed information, construction information, and delivery. So a kind of complete complete coverage of everything, all aspects of the design and build for private clients. So we only build new build houses, and we only build for private clients. And so where do we get started? So I'll take you through a little bit in terms of the history in a second, but the first bits are, what are the underlying ideas behind Facit Homes? And actually, one of the things we want to be able to do as designers is deliver interesting design and open up new possibilities. This is just a very simple illustration of the kind of things that people are building at the moment in terms of modular design. So big fabricated panels, there's a lot of talk about off-site fabrication. And the picture on the right here is one of the junction nodes from one of our construction projects. And the parameters that sit behind what we build are completely different to the kind of parameters that exist in what is kind of modular construction. And we're really interested in the design possibilities of these new processes and how it can allow us to build better and more interesting homes. One of the other aspects of what we do is we're passionate and interested in manufacturing. So Pedro and myself, we both have backgrounds in industrial design. And again, on the subject of kind of manufacturing and off-site construction, we are interested in how we can make the building using manufacturing processes and not in that kind of that idea of factory fabrication where everything gets done in one place. We're much more interested in a kind of distributed model of manufacturing, which has led us to develop some of the techniques that we have. One of those in particular is our on-site manufacturing system. So we actually bring our technology to the building site. And what led us to do this is the interest in the technology itself as opposed to off-site or on-site construction, and the want to actually digitize construction is really how we approach it as a whole. How can we apply digital technology to all parts of the construction process, be it the design, manufacturing, construction, communications, all of those systems together. So I'll give you a little bit of background on how we get started. I thought might be useful for you guys thinking about what you might do in the future and how you might start something of your own. So back in 2007, Actually, no, before that. So back in 1999. So I started originally my training. I graduated in 1999 in fine art, but before that, I actually did an industrial design degree. So as a basis, I'm kind of part industrial designer, part conceptual thinker, and that kind of follows through my history in terms of the development of this company. We're interested in how we make things, how we design, how we manufacture, and also the kind of bigger picture conceptual framework around what we do. So my first job was in Norman Foster's Architects in 1999, and we worked on all sorts of different projects. I started off in visualization and moved through into 3D design development, working on competition teams and all sorts of different projects, kind of working through from concept through to kind of stage 4, if you like. And one of the projects we worked on was this odd-looking thing here, which is a apartment block up in the hills in St. Moritz. And it was my first taste of parametric design, in that it was designed with parameters and a systems-based design, but also the frame of it was timber, and it was also digitally manufactured in Switzerland. So, that kind of opened my eyes to some of the possibilities. And after 3 years at Foster & Partners, I got a little bit itchy, and I felt like I was very removed from the construction process, and I wanted to get back and be much more hands-on. So I moved to do an MA at the Royal College of Art on a course which was called Design Products, which is broadly industrial design mixed with fine art. So it kind of matched my skill set, if you like. But it was actually a designer maker course. So everybody on the course was in some way making. And I spent 3 years experimenting with digital manufacturing technology. So I had things fabricated using CNC routing, stereolithography, 5-axis milling, CNC wire bending, and there's all sorts of different technologies that are readily available in the manufacturing industry, and were also very cheap. So that kind of got me thinking. And I kind of made very kind of sculptural things, but it actually formed the basis for my thinking, in that me as a person who can't actually physically make something with my hands, because that's not my skill set, how can I actually make something physical and realize it in the real world from my skills as a designer using computers? After my time at the RCA, I started up an architecture practice with 2 architects who I'd met at Foster & Partners, and we started right down the bottom of the pile doing extensions and refurbishments, and slowly working our way up over 5 years we ran the practice for, to eventually doing new build homes. And it couldn't be more different in terms of experience from making things digitally. We'd design things on computer, and then we'd give it to a contractor, and we'd hope to hell that they were going to build what we wanted. So at that point, I was like, there must be some way of combining our kind of architectural skills with digital manufacturing. And that led us to getting some research funding from Innovate UK. I think we had 2 different rounds of funding, maybe £30,000 and £40,000, something like that. And that allowed us to develop designs and build proof of concept. So this was built in the Architecture Foundation's old space, which was on Old Street. And through the funding, we were both able to develop our ideas, but also get our hands on a machine. So it allowed us to get access to pay for the overheads of a machine, have it in our studio, and really experiment and cut and make and refine and actually get close to the production. So we really understood it as a process. And that allowed us to kind of say, well, okay, we've built something and it actually seems to work. And at that point, I decided to kind of throw myself into it. And I left my architecture practice, and I fully committed to just getting this thing off the ground, and set up a company which was then called Facit UK, and tried to get some jobs. So the first thing we did is we placed an advert in, I think it was Build It magazine, to say, pilot scheme. Who wants to be our first customers? We were going to give free architecture fees. We were going to design houses for free for our first customers if they would let us build using our system. And we got a number of customers, and that led us to our first builds. One of which was on Grand Designs, which was filmed back in 2011. And that was when Pedro joined us. And through that process, we decided to invest in another machine, an actual production machine, which was this beautiful thing, which we still own and operate, which was an American-made, like really beautiful production machine. And we set up a company to pay for the overheads. So we thought, well, how can we make this work? How can we build one house commercially, exist, have a living? So we set up this side company that would produce CNC cutting services for anybody, just to cover the overheads of the machine, to give us the space to develop the company. And so we built our first few projects with very little. You know, we had a £650 per month payment on a machine and 250 quid on a couple of desks in a crappy studio in East London. And, you know, we just made it work. We existed off nothing for a good few years. But through that process, we learn. And after the first build, where we were really just doing the structural frame, then we moved on and we said, right, okay, let's take on the whole building contract. And so we took on this project, which was over £1 million worth of work, a massive house, super custom. We made all sorts of things, solar shades and staircases. We pulled in people that we knew who were part of our designer maker community, and we made it work in our own way. And then still to this day, we make it work in our own way. There's not anybody in our company who is from a construction background. We are engineers, architects, technology managers, financial people. That we don't really look like a contractor, but yet we build homes. And then from there, we started to just expand out a little, produce more homes for a wider variety of customers, and really start to design our back-end systems to be productive and efficient. We built our what we call our D process, which Pedro will talk about. We built it completely from scratch, and then we rebuilt it several times to allow us to produce the components that we want to produce in the right way, to allow the design team to have control over the design, and to allow us not to go insane as well, you know, as a bunch of small people doing fairly complex product design with literally thousands of components. And we took this approach to the whole company. So as we've gone on, we now develop back-end systems for our financial management, the way we communicate with site, how we track defects, and apply a digital and systems-based approach to all aspects of the company. So the same philosophy that we started with for what we call the chassis, but completely pervasive throughout the entire company. And what's the next slide? And one of the other key elements we've kind of moved into is even things like groundworks, really dirty, messy things. How can we apply a systematic approach to groundworks? How can we make it more digital? So we find the right kind of systems-based approach that allow us to do it with our team. So this is a particular foundation system that we like to use, and it's like a kit system, and we can build it with the same people who are building the chassis, and we can measure it accurately. So there's the similar approach to the digitization of the construction as a whole. We like to call this the digitization of the analog. Like even the most dirty, basic thing, putting paint on a wall, how can you make that more digital? And now we produce a range of different projects for different customers. And we're kind of fascinated as much by the design and the end result as we are by the process. For us, the process and the creation of the home is really the event. And it's what kind of keeps us going. So, I know I used to get frustrated with my architect friends who I ran the architecture practice with. They were very much interested in just the end result and everything between starting and getting to the end result was kind of just in their way, whereas actually our approach is to enjoy and embrace all the parts of the construction process and trying to make it something exciting. And I think that's me for the introduction. And yeah, Pedro is going to do his talk on the technical side.
Thank you, Bruce. Thank you for having us today. My name is Pedro. I've been working in Facit since 2011, and I've done pretty much every work in the company except being an accountant. I've worked in the workshop, I worked on site, and I'm working in the office. And the thing that I am in charge is developing the digital products for the company. The main one is the chassis, which is what we use to build our homes. The chassis, the Facit chassis, is a very streamlined solution to build timber frame. You can imagine it as a sort of plywood Lego in combination with some light timber framing. It allows us to make houses in a very efficient and precise way. And it has come through a lot of evolution since I joined the company, but I'm just going to tell you very briefly how it actually works. So we have a bunch of different things. We call them components. They are essentially plywood boxes that hold insulation inside. And they are structural. They are self-supporting, so they don't need anything else to hold themselves. They are the insulated structure. And we can use different things like window frames and pieces of wall, different types of gables and roof and floors to build the house. And starting from the architectural design, we put that into a very detailed model of the chassis where all the parts are stacked together exactly in the same way like you would make a Lego set. And we take a design approach that is called parametric design. So we design everything based on parameters or like the relationships of things with other things, values of height and width or depth or amount of insulation. That's the data that drives the design. I'll show you one. For example, on that component there, which is a piece of floor, we can control very precisely its form and its size, but we can also extract information from it. On this particular case, for the chassis components, we can also extract from it how many sheets of material do you need to build it, how many nails, how many screws are necessary to assemble it on site. And we can use all that information not only for the production of chassis, but also for the planning of the construction and creating orders and setting out schedules of how and when things are going to arrive on site. And that's a very powerful tool of using parametric design. It also allows us to very accurately coordinate other things that are not just the structure with the structure. Like, it's a little bit difficult to see here, but you can see things like the ducts for the mechanical ventilated system or pipes for drainage and plumbing, lighting fixtures. Everything can be put into the model and located. And then we can use things like clash detection methods to see if anything doesn't fit. And if it doesn't fit, we can change the parameters of whatever is around it and adjust it so we can design away most of the problems that you could find on site before it arrives to site. Then once we have a good model, that takes a few weeks, of the chassis, that then it's put into our deep process. The deep process it's the gateway to transform all this digital information in the architectural model into manufacturing information. And it has a few stages. The first one takes all those components that make the Facit chassis in the computer or in the architectural model, breaks them down into panels and add all the information that you need to put those panels together, like all the tabs and the pegs, holes for insulation, and also adds a layer of information into them so we can then identify them, so it assigns them a number that will then carry that component through the whole process, so then it can be located on site and be put in place where it needs to go. And these are the same ones that I showed you before, but this is what they look like once they are being put through the first stage of the deep process. And the second stage of the deep process takes all of those flat panels, lays them down into 8x4 sheets, and also create all the tool paths or the movements for the machine that is going to manufacture them, and writes all that information into a G-code file. It's just a file that contains all this information that then it can be sent to our manufacturing facility, either our own one, or if we need, we can also use third parties. We can outsource the manufacture. And that's what we use to manufacture the components. They can be built, as you can see here, on a workshop environment. I actually have a little video of the machine moving and cutting. That doesn't want to play, but that's fine. They can be built in a working environment, or we can also use our own, bit stuck, sorry. Yay. Or we can use our mobile production facility that Bruce told you briefly about before. The mobile production facility is essentially just a shipping container that contains our CNC router plus all of its ancillary equipment, dust extraction, computer. So you can load the files that were created by the deep process and throw material here and just cut the parts and build the components on site. And wish me luck. This video is going to play. Maybe not. But yeah, on site we can also manufacture the components. They can just take the parts straight away from the machine, throw them in the bench, assemble the component, and then put it on whatever it needs to go in the building. And why do we do this? What is the advantage of building a house in this way? Well, for one, the components are very light. They have a very high strength to weight ratio. So for the weight and the size, they are very, very strong. This is a photo of a destruction test that we did on one of our roof components. And as much as we tried, we couldn't get to destroy that thing. We ran out of cinder blocks, and we put as many people as we could on top of it, and the thing didn't want to break. It's also a very, very flexible system. Anything that you can express as a faceted shape, you can make it in chassis, and that frees us to design whatever we want. The designers at Facit are not constrained by the system. The system works for them, so we can make anything. The constraints are really what the client wants to pay for, really, and what we have time to make. And the main one is that the digitizing construction in this way allows us to create a very accurate copy of the design in real life. So like I said before, we can design away any issues that we find during the design process. We can see them, we can solve them. So when the components get to site, all of that has been, or most of it, as Jan will probably tell you, it's designed away. And also, this process is very reactive. So if everything is going well on site, or if everything is not going perfectly well, we can identify it. We can feedback that information back to the system and change the parameters that are not exactly working, generate the information again, and continue and solve it in a very streamlined way. That's the main advantage of the chassis system and digital fabrication of a house. I want to tell you about digital development of construction products, a little story, because it's interesting. And it's about our internal partition walls. We have done them differently across different generations of the D process and the construction system. And initially, when I joined the company, we did them just as CNC ply. Makes sense. It fits with the rest of the philosophy. But these partitions had very big disadvantages, that they were not structural, so we had to use to strengthen them with posts to be able to build floors and things like that. So we thought, okay, because price of materials and labor back at the time allowed us to do it, we moved to just make them with C16 lumber. But we still made them in a digital way, because we developed a parametric model of all the walls that we could extract information from. And they have been very successful. And those are the ones that we use in the project that Jan has been working. But now the price of lumber is going very, very high. So we decided to go back to the original approach, but try to make it structural this time with CNC walls. And our initial idea was to, now that we are making CNC walls again, let's try to integrate as much as we can into them. So we tried to integrate reinforcing posts and ducts and electrical conduits and sockets, switches, anything that we could locate, let's locate it, so then we can solve those problems. And so we developed our digital model, and we built a prototype. We built a physical prototype, which is an important step on all of our products. You can see me here very confused, looking at my own drawing, trying to figure out which part is which. And we finished it, we evaluated, and we just decided that it was too complicated. It was too heavy, it used too much material, it was very complicated to set up. In the Revit model, one single wall had more than 50 parameters that you had to set to make it work. So it was impractical. And this is where other parts of digital developing come in, because we use the information that we got from our physical prototype, not just the digital one, but things like the pictures that we took, and use digital tools of communication to speak and to send these designs back and forth with our structural engineers and within us in the office until we got to a design that worked. We settled on this one that you can see on the right with a few modifications. And the digital model was developed, it was integrated into the D process, and very relatively quickly, it became a physical product. On the picture on the right, you can see Mike. He's the client on the project that we have currently on site, looking very proud after building one of them by himself for his new house. And we like the D process so much that we are using it to do other things apart from the house itself, from the structural envelope. So we started using it a lot for staircases. This is the staircase on the Lionsdown project. And we took the same approach. We modeled it as a parametric object in Revit, put it through the D process, added all the manufactured detail, and it became a physical reality on site in a very precise way. It was very easy to install, and if you ever work with staircases, you know how fiddly they can be, and this was very pleasant to work with. And now we are starting to do, we are looking into integrate the D process into other things that are not plywood. So, for example, again on the Lionsdown project, we had this beautiful design, steel balustrade, laser cut and bended and to be installed. And again, we modeled it in a way that we could run it through the D process. And we again built a prototype. We took the lessons that we learned from that prototype into the feedback loop, into the model, and generated with very little post interventions, almost directly from Revit, all the manufacturing information so it could be made. And also because we had the exact object in Revit, we could make very accurate installation instructions for the site team. And it very quickly became also a physical reality on site, and it was very nice. So yeah, I like what we do because I think it's a very elegant way, like they said, to build a house. Each project has its own challenges, and I think it's something interesting to show you as well, because now I believe that the frontier between product design and architecture is getting blurred, and architects can think as product designers and learn a lot from the people that make things. And so yeah, I encourage you to learn more, talk to people that make things, and that will help you. And talking about people that make things, I'm gonna leave you with Jan, and she's gonna tell you a little bit more about the actual work on site, making a house.
Hi everyone, I'm Jan. I've done a few lectures at Westminster, and it's really nice to be back here today actually to be talking about timber. I've previously worked on site on different builds, working with sustainable material, bamboo, and for me, being on site in the action has always been a great opportunity to understand how things are put together. So I am a Part 3 student, actually at Westminster, and I'm kind of in the last throes of my Part 3. And I'm actually writing a case study about this project, so it's like the perfect thing for me to sort of close everything up. Being a site coordinator is also an opportunity to use the skills that I've sort of gained from previous projects, and I think it was a very good opportunity, and I was really glad that Bruce kind of welcomed me in to the company to sort of take this project into my hands and deliver it with a lot of gusto. So I'm just going to talk to you about the more physical aspects behind designing, behind building. Pedro so knew a lot about the actual design itself, and so this is kind of the reality of how you do something on site. So I started here. I began Facit in December of last year, and I started on Lionsdown Road, which is New Barnet, north. It's not really London, it's like north, on the outskirts of London, and started when it was really snowy, really cold, and the concrete slab had been poured, so it was, you know, the challenge was to kind of build off of this. This is my site team, and it's a mixture of skilled labourers, subcontractors, carpenters, and lead carpenters. These guys, my core team, and we basically take the drawings that are made in the office and all the information, and we put it together, and we just build upwards. And the build has been going, we're almost handing over now. We've got another 10 days to go, so it's quite exciting. And it's been a process of a team getting together as a team, and I kind of dedicate myself every single day to making sure that everybody knows what they're doing, their tasks, their roles, responsibilities, and just also keeping everyone safe. Health and safety is a big issue on site, and I guess I take care of everything in that respect. So here's the concrete slab is being poured to create this foundation, and then the chassis boxes, walls, headers, window frames, or windows rather, which hold the windows, they're delivered to site, and then we kind of stack them onto the sole plate, which is this timber edge here, which runs around the perimeter. This here. And everything is stacked on top of that, and it has to be super level, because, obviously everything is stacked upwards, and then if you start building, if you start to deviate away from it, by the time you reach second floor, it's like you're, 100 mil out. So for this project, we actually had the chassis delivered to us because we had them made at another factory. They were printed, assembled, put in a van, and then we had a company deliver them to site and very kindly drop them onto the working area. And this kind of didn't go so well in some respects because there were some errors there. Sometimes there were adjustments that had to be made. Sometimes the nails didn't fit in the right way, or the screws. And so we've gone back to our roots, I guess. We are now printing on site. We're with the CNC machine again. So it means that if there's an error, if there's a mistake, we can print it out again. And that kind of speeds up the whole process. I also take care of, I guess, the site area because, as you can see, we're in a residential area and we have neighbours on either side. And so we have a lot of issues to deal with. We have quite friendly neighbours, but there have been some moments where kind of planning conditions had to be met. We have deliveries which, take up the roadside and, getting here into, this steel delivery that day, it had to back up into the road, and then this was blocking traffic. So just have to be very aware of what's happening on site. There's the public walking on the road as well. Here we had a big delivery of the timber. This is from Bartram, and these are our posi joists. So they're lightweight, but they're very strong, and we've used them on quite a few projects. And so it's just offloading them as well onto the site. And then once we have the timber and all the materials, we start to build, basically. And so we go upwards. And then the team here have put up the walls and the headers and also the window frames. And then once the perimeter is all around the walls, then we go into the internal walls, which are stud walls, which are load-bearing and non-load-bearing as well. Just want to quickly go back about this. So timber prices have gone up in the last year. I think it's more than 100%. So for kind of reviewing of what's going to happen next, it's now happening that plywood internal structural walls are going to be used instead. So here we've used timber, timber lengths, 2x4s, 2x6s, but now we're going to do internal walls, which are plywood. Okay, and then this is the second floor, so moving up through the house. And then here we've got our sort of steel, they basically hold, I'll show you the next slide, but they basically hold the beams, and this shape will create the mansard roof, which is this here. So that will create that shape. And then this, on top of that, will sit the roof components. And so they're slotted in the right position. I don't think Pedro said that every single component has a number, so you can't really go wrong. And on the drawings, every single component has a place to go, which makes it very bespoke, which means that you can really tailor the design to what you want, and then the client, I guess, they can have a certain type of typology of building, which is really nice. These are the ventilated roof components, so they go on top of the breather membrane. Breather membrane, which is this yellow barrier. You didn't have a ventilated layer on the top because heat rises through the house, and so this creates another layer, a barrier, and then a plywood goes on top of that, and air can go through, so it takes away the condensation, so you're not getting condensation in the house. And this is where we are at now, so it's quite exciting. We've got a zinc roof, we've got rendered walls here, which are white, and we have this, it's like a cement board, it's called Equitone, and it's a special panel. And, just a little bit more. So these are our clients, Anna and Vina, so we're building a house for them and their family, And I like to think that we take into consideration their desires, their wishes, and essentially we're building them a dream house. And after all, we are called Facit Homes. We build homes for people, and that's kind of why we love what we do, I think. Here, we gathered the office together, and we had a topping out ceremony, whereby we signed the chassis and we dropped one of the chassis into the roof itself. And that was a nice day for all of us to celebrate. In my role, I also use a range of digital tools. So here I'm using the thermal camera to find out where no insulation has been put into the chassis. So basically these holes here, that's for something called eco bead, which is a small polystyrene bead which is coated in carbon, and they're burst into these holes there, and this creates a layer of insulation. That's one part of the insulation, and sometimes we miss the holes, so I get the thermal camera out, and it's just a camera that attaches to my iPhone or an iPad, and it shows you where there are dark places. So those dark places shows that there's no insulation there. So we get the guy to come back in and put some insulation. And I also use a 3D camera, which allows us to see, it allows the office to see where we are with the build and also where things were. So for example, if I take the shots in the same place every single week, I see the progress, and if there was a pipe there and it's behind the plasterboard, I can just go back to the week and say, okay, I remember there was a pipe or a cable somewhere. Just go flicking through the folders and I know that they're there. Also, I do a lot of dim checking. So there's a big difference between, the drawings that are made and then on site what's being built. So I get a lot of requests from my colleague to say, can you just check that please, run upstairs and just check the dims. So I'm always, with my tape measure, making sure that everything's right or not right. And also Pedro makes nice methodology statements about how to put things together. And then I go, I don't know if you can see that. Here, like for example, here went through this with Dan, and we went through all the problems that could come up, and do we have enough fixings? Do we have enough materials to do this? So it's good to kind of iron out the problems beforehand, before we start to build. I also work with the architect and project leader very closely, and I'm always sort of checking the subcontractors on their works and making sure that they know what they're doing. They've got their drawings, they're sticking to their drawings, they've got, here's the equipped, so they're doing all the AV inside, and just making sure that they've sort of put things in the right place. So it's understanding different trades, the plumber, the electrician, AV equipment, the microcrete, the plasterboard. I see everything, and it's really an exciting role, and I do encourage people who are not looking to go into architecture directly, but look into something like this, because you may not want to design, but you want to have the experience of making something. This is a really good way of kind of going to the industry. And it's not all fun and games. Well, rather it is fun and games. We do yoga on the roof every Friday, and this is just to do with me and my experience of, knitting the team together in a way where we can bond, because it's hard physical work. It's not easy. We are on site every single day, in the rain, in the snow, in the cold, and it's a challenge. So we have to be able to stick together and and help each other. And so even something like this, where it does enhance body and mind and spirit, it kind of brings us together. So I just want to talk a little bit more about site responsibilities. So my role is really key because I am in the middle between the site and the studio. So I am the bridge that I report basically everything that happens, and it's really important to record where you are, because everyone has contractual responsibilities, and the office have kind of no idea. They're back in Angel, and I'm on site, and people, my colleagues need to know the sequence of things, and are we sticking to the program? Are we going to tying into the budget? So it's a role that's very active and very much I need to know what's happening all the time. So I do love it, and I think I do bring another aspect to the company as opposed to just a traditional contractor who may look at different things, and I look at it from kind of more architectural perspective as well. And also, we're a great team. There's about 15 of us in the company, and it's not a huge company, but everybody has a specific role, and we all use our strengths and skills. And this is the final shot of where we are now. So this is the back of the house, and as I said, it's almost over. So we're going to be doing the landscaping all around. So we're branching out into landscaping here, and it's good to come and explain with my colleagues as well the whole project. So, thank you very much. I think Bruce wants to say a few things as well, and also maybe if we can show the video at some point, because it's a really good way of seeing how things are printed. Maybe Pedro, you can bring that up in a second as well. But I'm just going to pass it to Bruce again.
I'm just going to close on one slide. Really just talking about what the future looks like for us, but also maybe for you guys. We really believe that using digital manufacturing is really going to be pervasive in the future. And the way that we're approaching it is that we're moving towards manufacturing more and more and more of the building as we go through time, and as there becomes a bigger shortage in skilled labour and unskilled labour, and particularly in the last 12 months we've really felt this change in the availability of labour. Is suddenly the things that people thought were 3 years down the line have suddenly come to the forefront, and everybody in the construction industry is looking for solutions and new answers. So we think that one way or another the types of approach that we're going to take are going to be much more common. I guess for you guys, maybe have a think about that. That's it for me, but thank you very much for listening. And maybe, are we going to take some questions? Okay.
Please raise your hand. A microphone. Questions?
Yeah, there's one back there.
I have a question. What is the estimated lifespan of your buildings?
The estimated lifespan. So it's an interesting question. Timber buildings will last as long as you look after them. So some of the oldest buildings in Europe are timber. As long as you maintain the roof, it's the same as any kind of masonry built construction. Most traditional houses are brick skins with a timber roof. And if you don't maintain that roof, even a brick building will crumble over time. So timber buildings aren't in any way different from any other kind of construction. As long as you keep them looked after, they'll last forever.
Okay, thank you.
Anybody else?
I'm just curious, how do you approach your design in the initial stages? Because you control the process so carefully. Do you sort of start off with an initial floor going forward? Do you aim to finish the entire design before anything happens on site?
Yeah, good question. So the initial stages of the design process are fairly traditional. We're talking to the client about their needs and requirements and working through with them to build them a house which suits their desires and cost. So we'll go through, for the first few stages, will be very traditional, hand drawing, sketching, moving through into a CAD plan, agreeing that with the customer, and then into 3D. Really most of the constraints that we have in terms of the design are really cost. So, we could do anything. We could be much more extravagant than we are, but where we're positioned is to build really good quality, well-designed homes. We're not, trying to reinvent the wheel per se in terms of design, but we do get slightly more adventurous as time goes on. Then in terms of specification for the house, we try and nail everything at stage 4 before we go on site. That's where we're moving towards. In the past, because we're design and build, there's been a tendency to just do it on the fly because we can and we don't have to formally tender things out, but it's not very productive. You end up doing more redesign work, so we lose money in design fees. So the whole studio's moved towards signing everything off before we get on site, every single thing, and then sticking to it, which is more productive and more efficient in terms of design.
Okay, thank you.
No worries.
Do you think, you didn't say much about the services, things like water storage and those kinds of things, which, given climate change, the building regulations are likely to have to take account of these issues to do with separating water and so on. And I wondered, in your design system, which is primarily to do with the construction and volume control, do you work with engineers to do with water and services?
So from a sustainability perspective, we haven't really touched on sustainability today, but we've always designed our houses to be passive standard. So we're building high performance, airtight envelopes, triple glazed windows. And then from an operational perspective, we try and keep the buildings very simple. So we have a underfloor heating system built into the slab at the ground floor, heat recovery system recirculating the air and keeping the fresh air circulated throughout the building. And then from M&E perspective, it's pretty straightforward. We don't have, we have a heating design engineer who we work with to specify, at the moment we're specifying a lot of air source heat pumps. Electrics is pretty traditional, there's nothing particularly complicated. In terms of water, we do or have done analysis in the past for rainwater harvesting. I don't see the sustainability in it because the amount of plastic and concrete and electricity that you need to run it outweighs the carbon footprint of actually how much, you know, if you look at the carbon footprint of a litre of water in the UK, you know, so what we try and do is analyse things for what they are in terms of heading towards net zero. That's our kind of criteria, if you like. So, you know, when we're measuring things like the insulation was a really big change for us because we used to use cellulose fibre, which has got a recycled content and is, in theory, more sustainable. But actually, when you look at how well it's installed, what the U-value performance of it is, and how much energy you're going to save at the end of the day, that's really what defines how we make these decisions. So we try and take a very analytical, measured approach to all of the sustainability decisions that we make.
Thanks for an amazing presentation. I've got a question, which is a sort of customization question. I mean, what you're doing is so different from you know, what most architects even get a chance to do, because they're decoupled from the process of manufacture, whereas you're very tightly coupled to it. But the question about customization is because you get experience with each building. You get feedback, and the feedback's obviously tuning, you know, the design of your D process and the sort of computational breakdown of the shapes into things which are makeable. But my question is, because each time you do it slightly different, how useful are you finding the feedback from one project to help you, as it were, to be sort of loose with the customization of the next one? Is that still a real struggle?
So the approach that we have is that we have what we call our core products, right? So fundamentally, every house that we build is the same. It has the same chassis, the same heating system, the same door sets, the same window system. And what that allows us to do is each one we build, we record, we measure, we take that information back, we redesign components or interface details, so we evolve it over time. That is absolutely critical to our process because, you know, the advantage of our company over the competition, particularly independent architects who we tend to compete with, is for them each time it's new. They're trying a new system, a new structural framing, a new something, and they're on the way out to build schools and then hospitals and airports. And, you know, we're here. We don't want to do anything else. We just want to get better at this over time. So actually physically making stuff, analyzing it, measuring it, and putting it back into the system is really critical, and it's something that we're very privileged to be in the position to do, I think. And I think it's an unusual place to be, but it definitely it's definitely exciting and interesting, and it definitely gives us an advantage to make a better product and learn. But in terms of customization, we're still, I don't feel like we're constrained by our tools at all. I feel like the only, as I say, the only real constraints are the type of customers, and most people have a budget constraint, which is the market value of their property. They bought the land for X, they're going to spend a bunch of money on it, and they don't want to be putting £2 million into a property if they're going to lose £1 million of that. So that's generally what defines how extreme our projects are, if you like, or how customized they are.
Thank you very much. That was a very interesting talk. I just wanted to ask, as someone that comes from a fine art background, how would you suggest that we make the transition between a very conceptual design proposition to a more minimalist and straightforward type of building or final project?
Can you repeat the question a bit? I'm not quite sure what you mean.
Right, so you mentioned that you did fine art, which sort of made you a conceptual type of designer, but I realized that a lot of your projects have very minimal and straightforward components, basic components. So how would you suggest that we make the transition between a very conceptual idea to a simple and straightforward final proposition?
That's a good question. I think it has something to do with making. I think it's to do with getting close to the means of production in whatever way you can, and experiencing fabrication. And all you guys, I expect, can use computers and do modeling and design things. Those are the only tools you need now to be able to go and make stuff. There are so many available manufacturing tools in the environment that you can go and use. I would suggest trying to, move closer towards those things, or particularly collaborate with other people like Pedro, who've got that very specific skill set of industrial design. Look at our company, it's like split down the middle, architecture and industrial design. And I really see that. I see more companies in the marketplace or in the bigger world trying to take a similar approach, which you see, I don't know if anybody follows the kind of business news, but last year there was a big company called Katera, a US company, who were trying to do everything, design and build, manufacture housing at scale, and took billions of pounds of investment. But they didn't succeed, but the idea that they took was to be what they say is vertically integrated, where you do literally everything through your whole supply chain and you try and connect all the pieces. We do that on a very, very small scale, more successfully than they did. But that is really interesting, and there's lots of companies who are trying to pull these things together. There's a few companies. There's Sidewalk, who is Google's construction company. There's quite a few companies that I'm seeing starting up where they're really trying to pull these things together, architecture, manufacturing. So I think it's just be aware, be educated, try and get as close as you can to these kinds of technologies, and reach out to other people who are from a different background. It's really that combination of people working very closely side by side that makes it work. The fragmented nature of the construction industry, with architects over here, builders over there, product manufacturers over there, that's the biggest problem that we have to overcome. And it's not that complicated, but you need a different business model. You need a different delivery model to actually make people work together and not work in their own interest. In traditional contracting, everybody's working for their own interest. The architecture firm is working for design fees, the contractor's working for their construction margin, and that they are kind of at odds. So it's quite unusual to see projects where people really truly collaborate.
Thank you.
No worries.
Thank you for a very exciting presentation. I just want to ask one thing. I noticed Jen used a special thermal camera to identify, whether the insulation is there or not. So during the design process, did you use any performance prediction tools to understand, the predicted performance?
No, actually, we don't. The functioning of the properties from a kind of technical perspective is very straightforward. You know, we've engineered our construction detailing to minimize thermal bridging as a principle, like just the fundamental principles of how we design the structure means that we never really have to worry about heat loss. There's not really any requirement to make our properties work. You know, we're not designing full passive house properties. They're passive standard envelope, which means that the envelope is to a high or low, whatever, U value. But to actually design a passive house, you've got to have the right orientation, the right various hoops that you've got to jump through. We're more interested in delivering houses that are applicable to a wider audience, if you like. We kind of feel like we're judging that kind of level to say what we call is environmentally optimized. You know, we're trying to do things which we can apply across the board that are very sustainable, and you know that you don't have to have a particular site or orientation for it to work. If that answers the question.
Yes. The follow-on question is how will you guarantee the performance of your building? I guess most of your buildings are naturally ventilated.
They are mechanically ventilated, so we're using heat recovery ventilation. We always design it so we've got natural ventilation for summer cooling. So again, we're very kind of simple design philosophies for cooling. You know, we make sure we've got windows that can open ventilation on the ground floor. We get some mass through our slab, which is generally exposed on the ground floor. We stack vent it through the stairwell, where there's always an openable roof light in the center of the building. So again, just trying to follow quite simple principles and design buildings which are quite robust and not overcomplicated.
Thank you.
I would like to ask, how long does warranty or guarantee last for?
So the warranty on the properties is 10 years, and that's usually through like a third-party warranty provider.
Thank you.
My next question was how much did I get? No, look, thanks so much, and it was so nice to have the whole team describe all aspects of the project. And what's quite interesting to me is from the first time when you came to talk here, you know, many years ago, 2008, how successful the original kind of model is, and actually how much of that still exists, which it does, and the sort of brilliance or the brilliant utility of, you know, 18 mil ply, you know, and all of that stuff. So that's what's also really interesting, you know, the manufacture of the stuff, the fact you can manufacture really most of those components in a shipping container with one machine, and obviously one brilliant technical person.
Just the one, Pedro.
Well, it's the one, and then also brilliant site manager and yoga instructor. And so I think it's. But construction innovation is so rare in a way, so that it's just really great to see a different way of constructing something actually, and that you've continued to develop it and build on it. So thanks so much. That was great and a really good question.
Thank you very much, and thank you for such interesting questions as well. Thanks.